class.net. So in this video, I'm going to show you our first version of a basic message queue, courtesy of Redis here, Redis server running. I'm also going to be using Redis client, this one right here, as well. For my Redis server, I am just using the default here of port 6379, nothing fancy yet, but everything's all local here. So I'm going to go in, flush all my data in Redis from previous sessions. So what we've got here, I'm going to be showing you Xcode C++, Apple Xcode on my Mac book, and then of course we've got PyCharm, which I've been using a year now, another Python script that will send over a pilot data into a Redis instance. Okay, so I'm going to fire up both programs. So I've talked about the publisher subscriber pattern from Redis. Now with Redis, you can use this as a convenient way to push data into a database, both on the Python and the C++ side. So in this case, my C++ is the subscriber, and my Python script that I'll show you is the publisher. So I'm going to fire up this guy. So you can see here in my output, it's subscribing to Apple, the topic Apple, AAPL. So what I've got here in my Python side, I'm going to fire up this guy, and I'm just going to run it, and I'll walk through both the C++ program as well as the Python script. Okay, so what we're doing is I'm a bad boy. We need to run this guy. Push Redis, this is what we want. Okay, let me make sure I got that running. Okay, here we go. So what it's doing right now, it's pushing a pilot data into Redis. What is that data, you may be asking? Well, I'll show you that in a minute. But you can see here, there is a pilot activity where it is sending a bunch of data into the C++ via Redis. So let me just stop the script. And you can see here on the C++ it's stopped as well. Okay, so let's go through the details. Now I'm in Python here. What we're dealing with is a file, okay? Courtesy of here. Let me just see. I haven't really used this before. So I'm just switching everything over from Office, Microsoft Office to LibreOffice. So I am going to do this for the first time. And here. Okay, we're going to open up a file in my project. So we want this one, positions, yeah, right here. So we're going to open up this one. Okay, it's actually a text file. So let's just see what happens here. There we go, cool. Okay, so what we're really doing is this file is from IQFeed, okay? So what we're dealing with is a date, time, open, high, low, close, and then the volume. Okay, I've talked about extracting this data out of IQFeed, so I'm not going to go there. Just go under my proper playlist under IQFeed to follow that. Okay, you can see here we've got, I think it was 21,000. Okay, it's not so much, but it's quite a bit. Let's say a few thousand. Okay, cool. But you can see here, the important thing is it's minute data. So these are minute bars, okay? So just remember that. All right, so I'm gonna get out of here and back to the code. So once again, this is now Python that we're looking at. So what are we doing? Well, this is our main part right here. What we're doing is essentially right here. We open up this file I just showed you, okay, and we connect it to Redis. Okay, and what we're essentially going to be doing over the long run is it will go into here, into the data folder, and cycle through all the available files that reside in that file, in that folder. It's using this right here. And then once we know the name of the file, we extract out some info, and we need to convert the AAPL into an actual symbol name. So it extracts splits by the underscore, takes that symbol, and it will read that CSV file I just showed you. And then what it will do, it will go through that file I just showed you in LibreOffice right here, line by line. Okay, so what it's going to do though, it's going to maintain a rolling window. So here I've got this thing called num, really genius variable name, I must add. So it's going to roll. It's going to maintain a window size, rolling window, or sliding window of 80 rows. So 80 rows of these guys. And then from there, it will extract the header, or the first number of 80, or number defined as 80. It will drop the very first row and do some calculations. I'll show you that in a minute. But continuing on the loop, we create a data frame from that rolling window, because we're already maintaining it, but I'm not showing you the first iteration of it. But we get a data frame. It starts out obviously empty, and then we do some calculations. The ATR, well, print that out if you want. Don't need it really. And here we use a metrics function. I'll show you that in a minute. And then we calculate our intraday data as well from 24 hours of intraday data. That's from this data frame that we just extracted from our rolling window. Then we run another function to calculate our positives and negatives for our stats, get the size of the data, and then basically print that out. I'll show you that in a minute. And then what it's going to do, it's going to take all that data, the row that's extracted from the rolling window, and push that, because here in the queue is the Redis right here. So it's going to push that row using that symbol that we talked about, that's extracted up here. So it's really a list that's extracted right here. Okay, so it becomes like a list. So we send over the first element, which is the real symbol name. And then at the same time, that's our topic for the Redis database, or the index, and that's the data we're sending over, a row, which is essentially a string, comma delimited. Now I want you to pay very close attention to, which I normally wouldn't do. I would not put a comma at the end of this string, but I need to do that for my C++. I'll show you that why. Okay, so we've got this loop that we've covered. So what are we actually calculating here? Now I've talked about in numerous times, you know, before you actually put on a position, you're going to run. Actually, let me reverse this. I'm going to rewind a bit. It's really important that once we are going to run this kind of script, we already know this is a stock that we're very interested in trading. In actual fact, we know we want to trade it, therefore we've already assumed that we're going to put a position on it. Okay, so we're going to enter the market at this point, And what we're really doing is just using this position and maintaining it while it's in the market, while it's open, to do a bunch of calculations to calculate when to exit that position or exit that trade. So that's what all these calculations are for. So what we're doing is, as I said, we're using ATR, average true range. And we've got a bunch of other ones here called metrics, as a generic name. Beta, alpha, R squared, volatility, and momentum. So we're calculating that. Not only that, but we're also doing a pile of statistics on it as well. So there's like 3 major algorithm types that we are using as data to measure if we should get out of that position that we've assumed that we've put on, right? So let's go through each of these. The ATR is one of the first ones. Now I've talked about these in the past. I'm not going to go into great detail with these or where to find them, but they're out there. So this first one is we're doing this ATR calculation. We just basically take the high, low, close. We need the previous by doing the size of the window, blah, 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 calculate the true range, and then initialize our ATR 0, calculate our mean of the true range, and then we run through a loop to calculate our final ATR, okay? That's pretty well standard, but this one's specific for Python. Now, if you really want to know where this comes from, I've got my Python algorithm course that goes through this, and that's where it came from, and it's from a book, and I can't remember the name of the source where that came from. Okay, so let's talk about the next one. Let's start with let's do the stats first. The stats function. Once again, this comes from that same course that I've mentioned before, the Python algorithmic trading course, the infrastructure building block. This same function comes from that course. So you can see I'm using a lot of that material for my current, what will be my potential scripts for both my analytics service and even potentially trading. But I'll talk about that in a minute. So anyways, we got our stats. We've got, now here's the key. It has its close of the bars, and it calculates a return on the closing price, calculates our number of positives and negatives. This is really important to me because this shows downward trend. But what I want you to understand here is this function that gets called stats. This is what I'm assuming. And what I'm showing you calculation-wise is never final. Of course, I'll be adjusting this as time progresses to get it more accurate and more, just basically make the forecasting better. So this is going to be a consistently evolving set of scripts with the algorithms and calculations as the markets perform. And of course, I'll be tweaking things. But I've got all these stats or all these calculations available at my disposal to see what works and what doesn't. And remember, I don't think there is a foolproof way of knowing until you do a lot of experimentation. But the one thing that's really important that I wanted to show you for when I'm sending this stats function is this right here. Okay, now I mentioned this earlier, intraday. Now you will have a pile of data from this file, the CSV, which is Apple, right? And again, this is from IQFeed, a 1-minute data file. So what we're doing is we're extracting the last 24 hours worth. So we know there's 60 minutes over one working day, okay? So it's really a complete set of intraday. Now I can easily adjust that if it's a full 24 hours for the trading session, but we want to get a general idea on, when I go back here, this is what I'm really using, is positives and negatives. So what I'm looking for is a general trend for the day, for the last trading day. So if I know there's more positives than negatives, I know we should theoretically, just from that simple logic, we have an uptrend. And if there's more negatives than positives, then we also know theoretically, we have a downward trend for the previous day. Okay, so out of that, we can also extract out with the stats. Again, this comes from my infrastructure building blocks Python course. We've got the skew, mean, standard deviation, kurtosis, upward band on the standard deviation, and it doesn't stop there. We now can set up buckets with confidence levels as well, and then do some other fancy dancy, setting up the number of statistical, which will basically build a histogram. So his logic is built as part of his function. But if I really want to make, obviously, the function much faster, I just strip out the stuff that I don't want. And then right now, all I care about is this, the positives and negatives for downward or upward trend from the previous session. All the other stuff may be useful for me, and I think it will be, but I can easily return that back to my main function here, which can easily send all whatever data I want into Redis. Okay, so I have that at my disposal. Now, we've looked at the ATR, we've looked at the stats. Now let's check out this one. This is a really powerful metrics function here. Okay, so we know the symbol. So another one, so if you want this function, this is a really powerful posting to get beta and all the other stuff that I showed you. So what we're doing is we're passing the stock price with the data. Okay, so do realize we're now using Yahoo data. So we're making an extra call out to Yahoo to extract, call it better data, I don't know. And then we're also going to do the same thing against some kind of benchmark because we're using beta. So we need to compare our stock, at current stock's performance to measure it against some form of a benchmark. So in this case, we're using the S&P 500. Okay, so we get our returns, we get our adjusted close, we extract that out, and we do some manipulation here on the data for both the benchmark, the S&P 500, as well as our own stock that we're sending over. From here, we get a covariance matrix that gets built out, some fancy stuff here. We calculate the beta, which is what we want, alpha, plus we can do an R squared as well. Not only that, but it gets fun because we can also measure volatility, we can also measure momentum. Momentum's no different than the uptrend versus the downtrend on an intraday level. Because we're using minute day data, this really won't be that important because what we're doing here, capturing from Yahoo, that's really end of day data. So this particular momentum, I don't think will be very useful for me at this point. But if I want to use it for a longer term view, end of day data, this particular momentum may be useful. But we're using intraday. So all the data that comes out of this function, the metrics one, is intraday because we're making a call again to Yahoo for end of day. Now, I could also change that by passing different data, but that's all I care about. And I do believe our date range for end of day is 365 days a year, or I could really adjust this to 240 for 240 working days. But so we got our momentum. So now you can see here we got to annualize and then do some other calculating. Boom, boom, boom. We just return beta, alpha, R squared, volatility, momentum. Okay, so here we are. That's what we have. We have all this data. We build this string out. So remember, we're just doing one stock. We're sending over one stock's worth of data, performance, into Redis. Okay? So what are we sending over? We're sending over the ATR. So in our ATR here is going to bring back a lot of ATR. But here, all we care about is the most recent ATR, the last one from that list. We send over the beta, we send over the momentum, we send over the positives and negatives. Don't forget about that extra comma. Now, another thing that I should be sending over is a co-integration using either, I should say a co-integration test between the two. Also using either Engel Granger or Johannesburg or whatever it's called, one of those tests. Just to test and get a metric on the potential of true co-integration using either of those tests. So that's the C++. So let's go over to that's the Python. So let's check out the C++ side. Now I've gone over the C++ with a Redux, so I'm not going to go into great detail there with a Redux C++ wrapper to high Redis for Redis. So we've talked about the previous videos how to set up a subscriber. Now I purposely kept this brain dead easy. When I say brain dead, you've heard me talk about multi-threading, but I'm just essentially spawning a new thread and running this new C++ function. So I'm keeping it really brain dead, brain simple. And then I do a join to kick it off. Okay, so as I said earlier, do remember I'm only tracking one stock, but when I add on a pair, it complicates things. When I start to add in from here multiple stocks that I'm watching and pushing data through and calculating, this further complicates the C++ side with the multi-threading. So I have to figure out the optimal way to handle that. Very important stuff. That's why I really think when it comes down to performance on your trading system, multi-threading is critical. And from my point of view, going through the heavy learning on multi-threading, I think the approach that I'm using is probably the best for now, using the standard C++ multi-threading library. So that's what I'm doing, but I'm keeping this particular program very simple. But let's go through how we handle the data from Redis. So what we do here is we need to set up a publisher. We connect into it. We set up a subscriber as well. This we don't need, I don't think. But we set up and connect into the subscriber. Okay, and then we have these auto variables that we set. First, let me address these two, the subscribe and unsubscribe. When these get called, and notice that these are lambdas right here, we have control of it to do something within these steps. When you say you want to subscribe to this particular, in our case, a variable, or sorry, a stock, as a topic within Redis. So what I'm saying is here, we're subscribing to a topic called AAPL, Apple. But when I'm thinking about it, moving forward, I will need to create a generic topic called orders, and then attach the symbol as part of this data set here. Okay, so I'll come back to that in a minute, because I know it's confusing. All right, so as I said, we set up a lambda for subscribe, we set up a lambda for unsubscribe. So what we do somewhere in our code, eventually, we set up a subscriber and say we want to subscribe to the topic known as Apple. Okay, so in order for that to happen, we have to have this weird while loop of just kind of like an infinite loop that we can control to say, okay, once we know we're done, set the exit loop to be true, to break out of this loop. And once we know that, and I've covered this in a previous video, that I know. So again, once we break out of this exit loop, we can unsubscribe from the Redis subscription of Apple. and clean up and then break the connection from Redis and then tear down the app. So you may be asking, well, how do we break that loop, this exit loop? Well, again, I've covered that. I'll show you that in a minute. So I purposely did not cover this got message. So what's happening here, let me just relaunch this. If you look at subscribe to Apple, what's happening is C++ gets kicked off, kicks off this thread, which turns into this. So this is the function that the thread will kick off or spawn, called Redis sub. So here is the function Redis sub. So what's happening within the code, we know we want to subscribe to Apple. So it does that. So while it's subscribing, comes down here because it's subscribed. Now it enters in this while loop. Okay, so once Redis, because it's subscribing to Apple, it will trigger an event. So once we trigger that event, what event gets executed? Got message. That's just all predefined in our Redux library right here. That's how that's controlled. Okay. So let me just make sure I know what I'm speaking here. So right here. So when we subscribe, we're telling Redis when there's an event, execute got message. When you subscribe, execute the subscribe lambda. When you unsubscribe, execute the unsubscribe lambda. So in fact, when we subscribe and tell Redis that we're subscribing, when there's an event, meaning there's a message coming down the queue that is associated with Apple, execute this lambda. So this is what we're executing right here. So let's go over it. So we have our topic from Redis, and we also have our message. Now, this is basically from Python. It's this. So we know that this symbol is Apple, and row is the data that we've had in this previous Python script, calculates all the stuff, converts it into a string, and pushes that into Redis down the queue. So on the C++ side, when we subscribe to it, this will start to happen. Okay, so this is how we parse out that data. The topic and the message. Cool. So what happens is we can print out got message is, well, I think you saw it earlier. This is what's going to happen. So now we're going to parse the dates. Basically start our parsing, because that's what we're doing. We have our message queue right here, our message string from Redis. So all this stuff is about parsing out the string, which is the message, which again is this guy right here. So it's going to parse it up and split it into tokens by parsing using the delimiter of commas. Now remember, we have this little guy here. I'm going to show you why we need that. So that's what this loop does. It parses through the or splits up that string with a delimiter of a comma, and will basically be put into a token right here, if that makes sense. So right here, this is what we're doing. We've parsed up our message from start to end by doing this stuff. Now, if you need to really fully understand that, here's that link to do that. That's where the code got grabbed from. I always do that to make sure that we use this kind of like a set of breadcrumbs, so you can always refer back to it for greater detail. So we know that we've got our new parsed up message, and here's how we print that out, I guess. Now, coming back to our end loop. Remember our end loop to exit, or sorry, I should say exit loop. What we've done here is if, and I've shown this in a previous video, if we have a message of 10 instead of this data here, so instead of sending this in the row or as a message, and we just put in a string of value, let's say 10, or I could set it as exit or bye-bye or whatever. What will happen on the C++ side, it will send back a signal to exit loop, or set exit loop to true. So down here, this loop will exit, because now what we can do from the Redis point of view is we can send down some set of data, in this case 10, to exit the loop, to exit Redis. Now, there's this number of purposes I do that, or reasons why I do that, and it makes sense to do it this way. First, obviously, is to clean up the, it's kind of like an infinite loop. But the real reason why you do this, to set this message right here to 10, let's say, is let's say you have a panic situation in the markets, and you've got all these positions on. If you have this one particular position manager, and you're maintaining these open positions, which this C++ and the Python does, by sending this message, whatever it will be, it will tell Redis and this program that there's a panic, unwind your positions as fast as possible, regardless of what's going on. Because there's always a need for a panic button in your trading system. And this is kind of like how I could approach it. So somewhere in my data, I could say, push this particular message into Redis to tell this program, the position manager, to exit out of all the loops. Or I could do it by symbol or by whatever to exit that position just from the data, from executing the data. So essentially what I could do is, if I want, I could write a separate Python script or whatever it is, in whatever language, push a message into my Redis database. When I have listeners like this program, which is managing those closing positions, it will see that message being pushed through Redis, and I'll say, get out of this position for whatever reason, so I can have that run in a separate script. Or I can have another message saying, don't matter what it is, just get out of all positions, close them up regardless. So I have that full control using this methodology. Okay, so that's pretty well all the source code here. So what are the next steps? Well, this program is going to get bigger. And what's going to happen is there's two other purposes this program serves. The first one is it will actually temporarily execute all the trades with interactive brokers in my case. So that means you'll see more functions added to this to the C++ program to execute orders. Now, if you've been part of my interactive brokers workshop, you will have seen the various example code in my C++ in POSIX, the POSIX API from interactive brokers, to show you how to push that data or orders using C++ and the POSIX API from interactive brokers, which is, there's not a lot of demonstrations out there. Because I have that ability, I could have one of two ways of doing it. With the C++, with interactive brokers, I can communicate with either TWS, the Trader Workstation software, or the gateway, and also the fixed connection. So I have that flexibility from within those courses or that workshop, from that code, and then be able to implement that code into here. So that's the first next step. The second next step is essentially because I'm starting up my new analytics service, I want to be able to push out more charts. So in this case, I'm going to have the C++ on purpose. This is a choice on purpose to push out charts from C++. Now, I have talked a lot about new plot. You may have seen this video, I don't know, but I'm just giving you some more hints here. Hey there. If you go into my C++ playlist, right here, just do a search for new plot. So I have here some demos on new plot. A couple. Okay. So I'm going to use that library, which is open source, true open source, and generate some new plots, GNU new, or new, the word NEW, new, and have those plots generated and sent over into my analytics service. So the idea with that analytics service, it will show a chart, one chart of the stock that has a position with the, in my case, the targets for my soft target, as well as my stop loss. So we'll show those targets. And then that's when it, on the position of entry, and then there'll be another chart sent out exact same, but on the close or the exit. So it'll be able to show the open chart and the exit chart. Now, remember, those are the next two steps for this particular C++. Now, this is, if you think you're already confused, let's talk about the complexity. Now, I mentioned here, we're tracking one stock. But you got to remember, we are going to have basically a multiple set of stocks. Now remember, what I'm showing you is a pair of stocks, or should be a pair of stocks. So this demo is only focusing on one stock. So because I'll be now having to track a pair, I have to double up this string here. So what I mean is, what I've just shown you on the Python side will have to be not just tracked on the long, but I also have to do the same thing for the short and track this same data, all these calculations for both the long and the short, and push that in one row into Redis. Okay, so that means this amount of data you see here gets doubled up for one for the long and one for the short. In this case, I'm only showing you the one. So then on the C++ side, we're now tracking two stocks a pair. Okay, because we're tracking a pair, we have to at some point use both sets of calculations that I'm sending over from here. All these calculations, the beta, momentum, positives, negative, whatever. I have to figure out all those calculations on the C++ side and build a logic on when to actually exit the trade. Now, this is for one symbol I'm showing you, but there's two, a long and a short. So I have to figure out at what point do I exit the trade for both the long and the short. So I have to double up the logic in this section here, in this auto message lambda. Okay, so I want you to understand that. But at the same time, where it gets very tricky to maintain all that is this threading. Very tricky. Not only that, but I have to maintain the logic in here to figure out at what point do I exit that trade using not just one stock, but two, and build a logic on what metrics I use to exit that trade. So as I said earlier, it's going to be very long drawn out process to actually figure out what works and what doesn't work. So there's a lot of data I'll be playing with to figure out that exit logic. Okay, and as I said, we've got lots to play with. We've got beta, momentum, the stats, the positives and negatives. On top of, I'll be using just purely the logic of using co-integrated testing, like I said, Angle Granger or whatever. But not only is that, but we've mentioned this earlier. We've got all these metrics available. We've got the volatility, we've got the R squared, we've got the alpha that are not being used at this time. And the momentum on, in my case, in this case, it could be yearly data. I have the flexibility to make it monthly, weekly, whatever. Not only that, but I also have now the flexibility to use full statistical data as well, as I shown earlier. Standard deviation, mean, skew, kurtosis, on and on I could go. So I have all that flexibility to figure out, both on a mathematical or a technical analyst level, for an exit, what works and what doesn't work, and then feed it back into my C++ here, this auto message to figure out when to exit the trade. Okay, so I'll be moving towards that and finally demoing that, but I'll only show the new pieces. So this will be the first video you'll need to watch to fully understand it. But you can see, even though I try to make this simple, there's a lot of mechanics going on behind here. And again, this particular demo I'm showing you is very, very primitive and very simple. But it will get more complicated, as I said, as I add more data into it, because I have not even addressed any of the risk analysis, what's going on in the economy that could be used as drivers. I have not addressed anything against the risk against my portfolio, blah, blah, blah. So you can see how complicated this can get very quickly. And again, where the key of it all, because I'm choosing C++ for this, your threading is so critical here. And not just your threading, but what it comes really, really down to, from what I've been learning over the last, let's say, month or 6 weeks, what really is critical is the architecture and the hardware that you use. So for instance, if you're using NVIDIA GPU, you're screwed. You're royally, royally screwed. Why? Because here's the problem with NVIDIA and GPU, or sorry, CUDA. First of all, it's a very cryptic library. And not only that, but I've played with it. And you got to work with a non-C++ compliant library or compiler. So you have to go through this extra step to make it compliant for the library called CUDA to be able to implement that on the NVIDIA GPU boards. Now, if I was me researching what I've seen, regardless of performance, but we're just talking about convenience and adaptability, I would prefer to go with Intel. Now, for my research that I've seen, we have 3 separate Intel libraries from Intel. Not only that, but we also have the ability of the new coprocessor hardware coming out of Intel. And on top of that, we are dealing with probably the highest performant compiler out there from Intel. That's the approach I would go. And I think from what I've seen, a lot of the HFT shops follow the same approach for best performance using all the Intel hardware and multi-threading libraries on top of the compilers. So this is the route I'm going for this obvious reason, because it's another world to go into that's fairly complicated. And again, if you're still caught up in the world of Windows, boy oh boy, you're competing against a lot of other processes when you're running on a Windows system. But for now, let's keep it simple, as what I've already shown. Worry about that stuff down the road. Okay, hopefully those will help you out. Over and out.